In today's lesson, we will be solving systems with substitution. Your learning target says, I can solve a system of equations using the substitution method. Using the substitution method, we're going to do just that. We are going to substitute. So here I have my first system, and I already know what x equals, which is nice because I can start my ordered pair. I know x is 5. So then I can simply substitute right here and solve for y. So I'm going to rewrite that first example. Y equals, instead of 3 times x, I'm going to have 3 times 5 plus 10, and I just calculate that out. That is 15 and 10. So y is going to be 25. The ordered pair that is the solution to this is 5 from my second equation and 25 from the substitution. There's my answer. All right, I want you to try this, please, for the second problem on this page. And when you are ready, come back for checking. So pause me while you work. All right. So I can't start my ordered pair on this one yet because I don't know exactly what y equals, but I know I can substitute right there. So I'm going to take my first equation and rewrite 16 equals 4x, and instead of minus y, I'm going to subtract what y equals, which is 2x. So I simply took that out and put this in to that location. So 16 is now equal to 2 x's. If I solve that using divided by 2 on both sides, I'll find out that x is going to be 8. So I can start my answer. 8 is x. And this is actually a double substitution because now I can take this right up here. Well, if y is worth 2 times x, and x is 8, that's an 8, 2 times 8 is 16. That is the solution to this system. I'm going to have you try this one without me. It's going to need a lot of algebra, so take your time, pay attention to details, and pause me while you work. When you're ready for checking, come back. Okay, so I know that y is worth this amount. So I should be able to substitute y for negative x minus 3. So I'm simply going to rewrite this. 3 times x plus 2, but instead of the y, I'm going to put what it equals from the first equation. And that all equals negative 6. So let's do some algebra. 3x is good, but then I'm going to distribute. 2 times negative x is a negative 2x. And 2 times negative 3 is a negative 6. So all I did was I distributed. Now I've got some like terms I can put together. 3x's and a negative 2x is x, plus negative 6 equals negative 6. So it appears x has to be 0. Well, that's awesome. That's the beginning of my answer. So if x is 0, it belongs right there. Now this is one of those double substitution things. So if I know x is 0, I'm going to look at that first equation where I have my circle and my rectangle, and I'm going to put 0 where I see the x. And since I can't have a negative 0, it's just going to be 0 in here. I think I better rewrite this. This is getting a little confusing. So y equals 0 minus 3. So 0 minus 3 is a negative 3. That's my y value. It belongs right here. So 0, negative 3 is my ordered pair. So let's move into a story problem and see how we can use substitution to help us solve this. It said Missy spent $4 on pens and pencils at Target. The pens were 30 cents each. The pencils were 10 cents each. And we know she bought a total of 20 pens and pencils. So we have X for the pens and Y for the pencils. So we're going to start off with our equations. So my red equation, I know 30 cents times every pen, which is the X, and 10 cents times every pencil has to equal $4. My blue equation says the number of pens plus the number of pencils has to equal 20. So at first glance, this appears to not be a very good substitution problem because I don't know exactly what X equals or what Y equals. But never fear, I could alter this equation either for whatever I want X to equal or for whatever I want Y to equal. So I'm going to say that I want X by itself, although I could easily have said I want Y by itself. I'm going to go the X method, so I'm going to subtract Y from both sides. And when I eliminate the Y's, I'm going to have, let me get my pencil. My pencil went away. I'm going to have X on one side and 20 minus Y on the other. So then, a lot of steps here. I'm going to substitute. I know what X equals, and I know where to put it. So I have 30 cents times X, but instead of X, I'm going to substitute, plus 10 cents times Y equals 4. So we're going to do some distribution again. We're using all those skills from earlier in the year. So 30 cents times 20 is going to be 6. And 30 cents times negative Y is negative 30 cents Y. And then I just have the rest of the equation equals 4. Combine your like terms. 6 is not affected. Negative 30Y plus a positive 10Y. Oop, I shouldn't have an equal sign there. Let me fix that. Is going to give me, I did it again. Is going to give me a negative 20 cents Y equals 4. Solve. So I'm going to subtract 6 from both sides. That gives me a negative 20 cents Y equals negative 2. When I divide both sides by negative 20 cents, I will find out that Y equals 10. Boy, that was a lot of work. All right, so I know I'm going to have 10 pencils. My original easiest equation is right here. If I had 10 pencils, I also have 10 pens. So when I answer my question, it's not going to be an ordered pair. It says how many of each did Missy buy? So over here in green, 10 pens and 10 pencils. A lot of algebra involved with that one. Okay, on this one I'm going to help you set it up, but then I want you to solve it without me. So it says the sum of the measures of angles X and Y is 127. So X plus Y is 127. If the measure of X is 34 more than half Y, what is the measure of each angle? So I have my system set up right here, I want you to substitute, solve, pause me while you're working, and come back when you're ready for checking. Okay, so this one I have an x equals. That's fantastic. That means I can put what x equals in for right there. So instead of my x, I'm going to put 34 plus a half a y, and then I'm just going to finish the rest of that. I had a plus y equals 127. I don't have to distribute, but I do have to combine some like terms. So I have 34 plus 1.5 y's equals 127. Now I have a two-step equation. My first step, I'm going to take 34 off of both sides. That leaves me with 1.5 y's on one side and 93 on the other. My second step, I'm going to divide by 1.5 both sides. That will leave me y equals 62 degrees. Well, once I know what y equals, I can plug that into either equation. I think I'm going to plug it into the second one, although it doesn't matter which one I plug it into. So, x is going to be 34 more than half. Instead of y, I'm going to put a 62. So then I'm just going to calculate. Half of 62 is 31. So 34 and 31 together give me 65 degrees. So let me change colors here. So my x angle is 65 degrees and my y angle is 62 degrees, and I have answered the question. This one is all you. I want you to read it, see if you can find your two equations for your system, solve it, and then when you're done with all of that calculation, come back and check. So go ahead and pause me and get to work. So here are my equations. You have to pay attention to whether you're counting coins or you're counting value. There's our bell. All right, so it says I have quarters and I have dimes, and that gives a total of 59 coins. But then when I start talking about value, I have to take how many quarters I have times 25 cents and how many dimes I have times 10 cents, and that equaled $12.05. Now, it doesn't appear that we have a good substitution problem here quite yet, but I am going to alter this equation right here so that the number of quarters I have is going to be 59 minus the number of dimes I have. Okay, so once I have altered that, I now know that I can put the Q in right there. So I'm just going to rewrite 25 cents times Q, but remember, instead of that, I'm going to substitute what it equals, plus 10 cents for every dime equals $12.05. All right, it's time to substitute. 25 cents times 59 is going to give me $14.75, and 25 cents and a negative D would give me negative 25 cents D. And then I still have this, 10 cents D, and I still have this. Okay, so all I did was I distributed. Now I'm going to put like terms together. The $14.75 is unaffected. But when you add negative 25 cents times D and positive 10 cents times D, I'm going to get a negative 15 cents times D equals $12.05. two-step problem. First, let's get rid of our 1475. That leaves the negative 0 and 15 cents times D on one side and negative 270 on the other. Second step, divide by your negative 15 cents. Divide by a negative, 15 cents. And it looks like we're going to end up with 18 dimes. So I'm going to go back to this equation, the one that I used for my substitution. Oh, there's our other bell. I'm going to put 18 in for my dimes. So my quarters were 59 minus the 18 I just calculated. It looks like there are 41 of those. So to answer the question, how many of each coin do you have? I have 18 dimes and 41 quarters. All right, good job today.